This session explores advanced satellite communication for secure beyond line of sight military operations. Panelists, including military leaders and satellite service providers, will discuss innovation in COMSEC, TRANSEC, encryption technologies, and new waveforms. Key topics include quantum key distribution, post-quantum encryption, and industry's capabilities for reliable communication in contested environments. The session will also explore spectrum issues, insights on the global coverage, and integration with the defense platform, which will highlight the role of satellite services in enhancing military communication, resilience, and effectiveness. For the same, may I call upon the chair and moderator of the session, Vice Admiral Pradeep Chauhan, AVSM and Bar, VSM DG NMF. May I also call upon the panelist of the session, Brigadier Dr. Navjot Singh Bedi, Additional Officer DIA, Mr. Jeewan Singh, Account Director, Viasat India, Mr. Vinod Kaul, RVP Asia, Gilat Satellite Networks, Ms. Richa Hukumchand, Founder, Pramatra. Over to you, Chair.
Thank you very much, ma'am. Thank you for those great words of introduction. While we are waiting for the hall to fill up, let me begin this session by wishing everyone here and their families a very good 2025. Every indication is that it will be better than 2024, and you can take that exactly as you please. But please accept our very best wishes for the Happy New Year to all of you. Now, we have a very sterling stellar panel over here, which has already been introduced by our gracious moderator. So I'm not going to spend any time on that. I just want to tell you the sequence. We will start with Brigadier Dr. Navjot Singh Bedi, and then we will move to Ms. Richa Hukumchand, and then go to Mr. Jeewan Singh, and to bring us home, we will request the services of Mr. Vinod Kaul. I want to talk to you a little bit about what we are going to be hoping to hear from our panel. This is a fairly intimidating panel. And in other words, they have a fairly rich vein of expertise and experience. And so I shouldn't try and steal any of their thunder, nor make complete, nor dumb the session down unduly. In this session, we hope to be able to talk about issues relating to COMSEC in general and TRANSEC in particular. We also want to be able to talk about quantum key distribution and post-quantum encryption, which is really important right now for the reason that, first of all, advances in satellite quantum communications are aimed at reshaping the whole global telecommunication network by increasing TRANSEC. So transmission security has a increasingly large role to play in the future battle space, whether that battle space is occurring in the realm of defense per se, or it is occurring in the realm of the country as a whole. I wanted to emphasize a couple of things and leave some things for your consideration as industry. Number one, what I have found in the last few sessions that I've had the privilege of addressing in DefSat and more generally with the SIA is that it's not that we do not have an adequate amount of technological brilliance in India. We do. What we do not have is an adequate amount of imagination, which will then drive the technological brilliance of our industry towards meaningful endpoints. One of the problems is that when we move away from traditional forms of physics into the whole area of quantum mechanics and quantum physics, we run into problems of speed. Let me try and explain what I'm saying. It is hard enough for practitioners to try and wrap their heads around issues relating to quantum cryptography, quantum. There was a time only 2 years ago when if you weren't saying quantum cryptography, you were considered passé. 2 years down the line, we find that post-quantum solutions are now becoming so common as to bring into question the strength of a quantum-based computer to be able to break through an existing computer, existing communication, set of communication algorithms. Now, those of us who believe that quantum is still the answer to the breaking of a communication algorithm must deal now with others who are in, as I said, post-quantum communications and worrying about quantum key distribution and whether quantum key distribution can actually rest upon the old principles of a one-time pad, and quantum key distribution will allow us to have OTPs that are now impervious to the old mechanisms of strengthening computer-based communication algorithms, or not. In other words, we already have commercial. It's now 18 months since the first commercial demonstration of a ground-to-satellite and satellite-back-to-ground station was demonstrated as being impervious to quantum computer ability to break that algorithm. So, speed. One of the things that the government of India is known for many good things. Speed is not one of them. And yet, inside this whole relatively slow-moving edifice are some centers of excellence within the government which actually do manage to get speed going. And if you look at the government's, the National Quantum Mission, it has been now just about 2 years. It was established, if I'm not wrong, in 2023. And between 2023 and now, we already have some ambitions. We want to be able to launch a quantum satellite in the next 2 years or thereabouts. We know that ISRO has demonstrated some capability over some having free space quantum communications over some reasonable distance, which is not now being measured in meters anymore, but is hopefully going to go farther than that. And obviously that immediately brings in the whole business of satellites. Because the great advantage that those satellite platforms have is in overcoming what was otherwise and is otherwise well known to all military practitioners as the tyranny of distance. How do we get over this particular tyranny of distance? So when I say speed, I'm talking about speed of decision making. The largest challenge, I again want to reiterate, is not technology. The largest challenge is imagination, and the challenge is evenly distributed between industry and the military. And hopefully, as we progress these DefSat war games tomorrow, you will see that speed of understanding of the movement of technology and the imagination that is required to be able to understand where we might go with that particular technology are going to come into sharp focus. So, like I said, in terms of, there are so many bits and pieces of jargon which are not just jargon. And if we cannot get middle and senior level leaderships of the military to really understand this at functional levels, if we cannot get people to understand what is lattice-based cryptography, how does that impact them? How will it impact them by the time they move from, say, the rank at which they are to the rank that they aspire to, with time being compressed all the time? How is this going to happen? What exactly should we be doing? We're not even do our mid-level and our senior level leaderships. I think senior level leaderships do, but mid-level leaderships are problematically placed where it comes to understanding even the basic issues in application of, say, quantum tunneling, in absence of, I think quite a lot of confusion still exists in whether or not the basics of superpositioning, basics of entanglement can actually find practical application. Then we've got these other types of people, and they are that wo dekho chidiya kuch nahi hua type, eternal optimist. So don't worry, just give us another couple of months and you will see practical applications, practical quantum computers proliferating. But we know that that is not the truth. We also know, therefore, that there is not much room for pessimism, and there is not much scope left for optimism which is not backed by some facts on the ground. So where do our positions lie? And why am I emphasizing this business of imagination quite so much? Last point. It is this, that if we look at imagination, military imagination, often this is considered to be an oxymoron. But if we look at how militaries succeed, they succeed because of imagination. Does imagination therefore become the prime driver of technology? Should it be the prime? Is imagination within the realms of technology at all? Is it within the realms of the sciences? How have we defined sciences? We want to tell our people, all the time we are forever telling our people that science. So what do we understand by science? We understand science, technology, engineering, mathematics, the STEM series. Now some of us are thinking, and if you've come from an IIT anywhere in our country, you will realize that in many IITs there's a belief that there's some problem. So long as we can explain the CBSE kind of syllabus, A, B, C, D में से एक choice ले लो, we are fine. If we give him a real world problem in which there's a real world thing, he can't understand the problem. It is the problem statement that is defeating him. And therefore, my belief is that we are approaching the sciences with a certain lack of imagination. We are not being informed by all the sciences. We're not being informed by the life sciences. We in the Navy, we were trying so hard to find an airborne laser mine detection system that can be mounted airborne and allow us to illuminate mines close to our coast laid by our enemy. Not our mines laid on his coast. His mines laid against our coast. As soon as we said airborne and we said aircraft, every single man-jack thought about heavier than aircraft. How did you come to that conclusion? How did you come to the conclusion that all aircraft are heavier than aircraft? This is what I'm trying to say is a function of how much is your imagination? And what was your aim? So if the power you required was the power you required for the firing of that laser, this is not a quantum example, though I know that quantum is being utilized in this fashion. But for the firing of this laser was the same power that you were deriving for the movement of that helicopter staying aloft, then is there a possibility of using lighter than aircraft? Is that possible? If we used lighter than aircraft, then all the power that we had is neither limited in spatial terms by the aircraft's dimensions, the helicopter's dimensions, nor is it limited by the endurance of the helicopter. Then is that a solution? Can we merge these two solutions? Can we merge a much older solution, which is the lighter than air dirigible, with a much more modern solution? Can we not? We don't have an answer. We don't have an answer because we're not thinking about this particular problem outside of the specifics of our imagination. This is what I wanted to emphasize. We're going to talk about all these complexities of communication security, transmission security. How many of us aren't involved in areas where we're trying to figure out whether the enemy has demonstrated communication behavior indicating that he is in some state of readiness which is higher than his normal state? I think I'm about to overshoot my time. They're all nodding vigorously. So I will stop, but with one last point. I can't resist this. It's 2611. India has been taken totally by surprise by Ajmal Kasab and his cohorts. Yes, that's true. We were taken completely by surprise. Our belief is that Pakistan was taken equally by surprise. They also didn't know what was happening. How do we know that? Because if they had known what was happening, they would not have been able to discount the fact that India might have decided to go to armed conflict, go to war. But we were keeping nigrani on them. Hamari nigrani hamesha un pe rehti hai. We didn't detect anything. Consequently, we believed that if nothing was detected, no change in communication patterns, no intensity, no change, then they didn't know. That's a conclusion that we drew in TRANSEC. This is not a conclusion you can draw anymore. Because if his TRANSEC had been superior, he would have fooled us. We wouldn't have known. And therefore, can we do the reverse? Do we always have to be the victims? Can we be the perpetrators? These are areas that I think both military and industry would be wise to think about. But now I've really spoken enough, and I will now turn the proceedings over to this very illustrious and distinguished panel, starting with Brigadier Navjot Singh Bedi, who, as you've already been introduced, sir, is an additional officer with the DIA, and over to you.
Thank you, sir.
So I'm going to give each of you, say, 7 to 10 minutes. At 7 minutes, I'll start making unhappy noises. And at 10 minutes, we'll press this particular buzzer which has been given to me, which ejects the speaker from the podium. Thank you.
Yeah. Thank you, Chair. And thank you, SIA, for inviting me to this panel to convey my thoughts on this topic, very interesting topic. After that brilliant overview given by the Chair and the cursory warning, I'll plan to go slightly fast. I have no intentions of being ejected. So traditionally, communication satellites, we know they were with geo orbits and are capable of providing communications, though with a lot of latency, but primarily were used for other tasks. And they have been proved their worth since the 1960s onwards. They orbit at around greater than 35,000 kilometers above the Earth, and they're highly capable, have long lives. But by and by, the expectations increased. So now, though 3 satellites or geosatellites cover the complete orbit, but still there have been certain questions raised about the bandwidth that they provide and the capacity. Though recent technical advances, including new high-throughput satellites and reconfigurable designs, have improved both efficiency and performance, but a new entrant has come into the play, that is the LEO. These orbit at between 500 to 2,000 kilometers from the Earth, offer faster communications because of a lower latency, and provide higher bandwidth, which I was discussing with one of my co-panelists while sitting outside. And at times, it's better than what even is provided by cable and copper and some previous or prior to 5G transmission capabilities. Communication occurs through a constellation of LEO satellites, as global coverage requires a large number of spacecraft. So a LEO satellite will be orbiting in less than 2 hours, generally about 128 minutes. Means it's in view for only a few minutes, actually about 17 minutes or so. So LEO satellite will be making at least about 11.25 orbits per day, which takes a toll on its life capability also. Now, are these here to stay? One may recall that number in 1990s when several companies had tried to provide global coverage through satellite. Globestar, Iridium, Odyssey, and TELDESIC all had impressive plans, but all except Iridium in the end had to either scale back or fold it back because of the high cost and limited demand. I'm sure a lot of drawing board exercise and reworking has been done, because now the LEO concepts have undergone a major change in satellite ops, including manufacturing and supply chain, because now they ask more of a satellite and it's a shortened lifespan. Generally, the one says about 5 years or so, as compared to 15 years of a GEO. A few points that the chair and the panel is expected to address. I'll just touch upon it because the main aspects the chair has already dwelt on. Post-quantum encryption. Now, is also called quantum proof, quantum safe, or quantum resistant. It's very important. It's the development of cryptographic algorithms, usually public key algorithms, that are currently thought to be secure against a cryptanalytic attack by a quantum computer. Many countries are collecting data, storing it, which they are unable to decrypt, and waiting for the development of a quantum computer to work on it. So hence the importance of post-quantum encryption. Most of the public key algorithms rely on the difficulty of three mathematical problems, which we are all aware of. One is the integer factorization problem, one is the discrete longevity problem, as also the elliptic wave discrete longevity problem. Now, all these problems can be easily solved on a sufficiently powerful quantum computer. So, PQE derives its importance from the fact that it implies preparing for the advent of quantum computers, which could potentially break the current public key cryptography, which we assume to be fail-proof. And the PQ has thus immense potential in not only government sectors, but also in financial transactions, which we find that the finance is nowadays running the way the world works, in banking, etc. Now also, needless to say, it is important for secure military communications, but to optimally leverage it, there's a need to standardize the process for PQ algorithms to be followed by all. Quantum key distribution is a tech that uses quantum mechanics to generate and distribute cryptographic keys for secure data transition. Now it uses the unique properties of quantum particles or photons of light to generate random keys that are shared between two parties. These can then use these keys for encryption and decryption. QKD offers the advantages of unconditional security and high data rates. However, it faces challenges of technical complexity, which the chair had alluded to, limited range, and susceptibility to environmental factors. Very prone to it. Its future outlook, however, appears to be bright, and it has potential applications in sectors like banking, defense, healthcare, telecom, and government, which will all need secure key distribution for encrypted comms. QKD is considered to be foolproof because it is based on the laws of physics rather than on maths, which can at times be broken. It means even if computational power increases or improves in the future, QKD, as of now, will remain secure, but the human imagination knows no bounds. But as of now, that's why I quantified. Limitations of QKD are that it requires very special purpose equipment. Its characteristics are based on physical properties of the security it is derived from, the unique physical layer communications. And its protocols can, however, are vulnerable to imperfections based on the implementation, because the implementation is based on the human interface. For example, QKD is susceptible to man-in-the-middle attack. So it cannot be implemented in a software, so hence cannot be provided as a service like many facilities are provided. It is hardware-based and thus lacks the flexibility for upgrade. A bit about frequency spectrum, which is what I would like to actually dwell upon, this being a scarce resource, and it is required by both the terrestrial IMT and the satellite sector. And you would be reading a lot about this in the papers. Thus, there's a need for efficient spectrum utilization and international cooperation in this field. The first issue with regard to satellite spectrum is the allocation for LEO constellations, their pricing and utilization for defense and government and other sectors. Now, LEO constellations like Starlink and OneWeb, they use the shared spectrum. The government has decided to allocate spectrum administratively as per the space policy to LEO constellations. However, certain issues remain with respect to the pricing. Now, there's a virtual limit to the number of satellites that can be given frequency spectrum. So, there's a virtual limit on the number of constellations or applicants. Another thing, the LEO constellations are seeking to connect the unconnected and therefore seeking for subsidy under the USOF, Bharat Nidhi. Now, should there be Bharat Nidhi be allowed for connecting to already developed rural areas, urban areas, or only for the rural areas? Second issue is with respect to the NGP released by InSpace. NGP is norms, guidelines, and procedures. And after the release of the Indian Space Policy 2023, in which all non-government entities are permitted to establish gateways for providing services like telemetry tracking and control, MCC, and remote sensing data. So now this possibly reduces the dependency of government on ISRO. And one could possibly consider the option to use LEO constellations for connecting forward underserved areas and for providing BTS backhaul to existing mobile networks. The potential for sharing spectrum with other users is immense. Like, for example, commercial Satcom operators could be explored. However, it is, as far as defense is concerned, it should be contingent upon the primacy of the requirement of the armed forces. And the security being paramount, this is a very major issue. Spectrum warfare is a reality, and in the background of the growing threat of spectrum jamming and interference. The importance of satellite constellations for global coverage and resilience is well understood and has been dwelt on in passing by the chair. Now, if the LEO communication satellite is to be considered for military use, then it's very important there is need for seamless integration of satellite comms with various military platforms, such as aircraft, ships, and ground vehicles. There's also the aspect of the importance of interoperability between different satellite systems and networks. Additional consideration that one needs to factor in is the importance of cybersecurity in protecting military satellites. And potentially applications of AI, of course, and automated networks are also there, which help in threat detection. Now, recent conflicts have proven conclusively that about the limitation of geostationary satellite-based communications for military in various theaters. Though the limitation of the equatorial orbit for us restricts the RF availability, so apparently the only way out is to go for low Earth systems or LEO satellite systems. However, we need to put in place certain measures before we are fully ready for this. This is a policy decision, and once this is taken, rest everything including COMSEC, TRANSEC, antennas, systems, etc. flows from this concept, if one agrees to it. Companies are planning large LEO satellite internet constellations. They still need to reduce a range of costs specifically to ensure long-term viability. Lowering launch cost is one aspect, which some of the satellite launch operators have done. But it will be equally critical to reduce the cost of manufacturing spacecraft, ground equipment, and user equipment. If suppliers and constellation providers can achieve these cuts, they could unlock enough demand for large LEO constellations to transform both business to consumer and B2B communication markets. Military SATCOM solutions are not akin to what is provided in the commercial, need to fight through adversary jamming, operate despite ground station disruptions, withstand challenging environmental conditions, and mitigate an ever-growing set of attack vectors. To sum up, protected military systems need to be failure-proof, both in the technological domain and, more importantly, in the realm of geopolitical control, which is self-reliance and Atmanirbharta. Sometime back, you would be aware, the launch of some satellites of OneWeb constellation were delayed due to some geopolitical considerations. So the control needs to be with us. In my personal opinion, I reiterate, it's my personal opinion, advanced satellite communications will play a very critical role in future military ops for sure. But the budgets involved are a definitive challenge. Ideal would be to leverage cutting-edge technology like QKD, PQE, and AI in collaboration with the private industry, which is getting a boost not only in the domestic market but internationally. we can enhance the security, reliability, and flexibility of military communications and work together to find a way to overcome the challenges and associated with technologies such as spectrum scarcity and cybersecurity threats. Strong partnership between military and industry are crucial to drive innovation and ensure the successful deployment of these technologies. By working together, we can develop the next generation of secure and resilient satellite communication networks. And somewhere it had been come out that the market for the Indian space industry in somewhere 2033 is roughly about $32 billion or so. Thank you all for a patient hearing. And Chair, I yield with 1 minute to spare.
Thank you very much, Brigadier. As you can see, not all measurements of time are identical between two people, and therefore we don't have entanglement really. But let me turn to our next speaker, and that is Ms. Richa Hukamchand, who is the founder of Pramatra Space. And she's going... Yep. So you have a max of 10 minutes? Is that okay?
Much shorter.
Okay, good. Great. Wonderful. Thank you, ma'am.
Thank you so much, Chair. And thank you so much, the SIA-INDIA and the organizing committee here to provide this opportunity to me and even organize this event. I really feel that these kind of conversations are very, very important, and they are helpful for triggering thought-provoking decision-making and strategy for the growth of the technology and preparing all of us and our nation for the next generation of warfare. Pramatra Space is a quantum security venture, and we are on a mission to provide solutions against any kind of quantum attacks. We are building quantum key distribution satellite constellation, which will be able to provide a physical layer in the form of payloads or transceiver devices, which can enable a global secure ecosystem, not just for space, but also for the ground segments, right? So I would like to today highlight that there are a lot of myths and jargons being thrown, and this is quite common when a new technology comes into the ecosystem. And what I'll try, based on our experience of 1.5 to 2 years while working on this technology, the challenges that we highlight, that we came across. And so I'll try to highlight the challenges with full transparency and bring out what are the solutions and direction which can actually enable a global secure, global quantum secure space and ground ecosystem. So the first challenge that is, and few challenges were highlighted by Navjot sir as well, more in terms of hardware and implementation of this technology. The first challenge that I would like to highlight is the distance limitation. Distance limitation of implementing quantum key distribution communication channels, and this distance limitation is only on the terrestrial fiber optics. So not beyond 100 kilometers is what any kind of a key distribution network can be established. And that's why it's important to look at solutions which are free space in nature, and we are looking at satellite-based entanglement-based solutions which can enable distance coverage or distribution of these keys off of a range of around 1100 kilometers. Chinese did their first experiment in 2016 by launching their Mickey's satellite, which was of a similar range. There has not been any other experimentation globally which has proven that kind of a distant range, and we are on a mission for that. The other challenge is that, okay, how do you go beyond 1100 kilometers? That is building solutions or hardware which can provide inter-satellite linkages. So the end is not just provide entanglement or one satellite-based systems, but providing or building hardware which can connect the inter-satellite link. And the beauty about this technology is, and which should be leveraged and can be leveraged, is in free space, this quantum key communication channels can have very long range and distance. The major attenuation or the challenges that take place because of the loss of signals is the 10 kilometers of the atmospheric attenuation and disturbances that are caused when we are looking at satellite to ground communications. The second challenge is, which even I would say Navjot sir highlighted, is that this is hardware which is difficult, and this is not a software-based solution. You have to look at a hardware-based solution, and this is more going to the post era when, yes, there were dongles which were put up, hardware security more for key-based systems, and that should be absolutely fine, but we have to understand why hardware implementation is difficult, right? So the traditional quantum key distribution devices, which are being used either on terrestrial or on space, are devised or are designed using optical devices, right? And even the Mickey's satellite, which was launched, was weighing around more than 400 kgs, right? Whereas last year, German Aerospace Agency has actually launched their first demo satellite, which is with the name Cube 2, and that was their first experiment, was just 15 kgs. Now, how is that possible, right? It is again moving away, 90% of the equipment or the processes being operated on the optical devices. So we are looking at photonics-based solutions, shifting all the operations instead of free space and optical devices, rather than to a chip, or where the optical particles will move inside the chip. In fact, we have completed our first milestone of developing a one-of-its-kind chip, which is based out of integrated photonics, which has the capability to generate entanglement. By using photonics-based chip, you not even provide higher data key rates. It is also because there will be low losses as compared to free space optics. There will be, these chips production cycles are much faster than coming up with any optical devices, right? It's optical device usually requires mechanical alignments, any kind of a disturbances causes errors and deterioration in the devices, whereas if you're designing the system in a chip, these can be sturdy, and they can be produced in a much, like 4 to 5 months of production cycle is what the fabrication facilities have. So if you look at a national level, I think it is very important for us to build the fabrication facilities for photonics, and this is to catch up and be there in the race for chip war and be a leader in the photonics industry, so that the next generation warfare equipment can be built. The third challenge I would like to highlight, which I would say speak it on behalf of the end user. There's usually, when new technology comes up, there's a lot of debates that trigger that, okay, PQC or QKD or free space or satellite, right? I believe there's a saying that one size doesn't fit all. And that's what is the approach that we should look at here. For example, if terrestrial fiber optics has a limitation of just 100 kilometers, that doesn't mean that terrestrial optics will not be utilized or will not be used. For all your last mile distribution network, that is a technology which would be preferred. Whereas for a long range distribution systems, there's always free space and space-based QKD systems which would always lead the race. And similar to that, like PQC versus QKD, it is now, at least in the thought leader community, it is quite conclusive that it is not, these two are not competitive technologies. These two are complementary technologies where QKD or key distribution is looked at where data is in transmit, and PQC is more looked at when data is at rest, or for the key storages, you would want to store bulk of keys into some format. So for securing those hardware is where you need those mathematical based quantum safe or quantum resilient algorithms. I think that's from my end, and I would like to conclude. Our honorable governor's speech was quite thought-provoking and quite motivational, and I would want to follow that, because yes, you can have, with logical thought process and you can build businesses, but if you have to bring a new disruptive technology for our nation or at a global level, you need emotion. Emotion is what at times drives new disruption. And with that, yes, we are quite dedicated for our mission at Pramatra. When we started up, जब हमने चालू किया था तो नाम जो था प्रमात्रा, ये कैसे रखें, और जब मैंने ग्लोबल लेवल पे सारी कंपनीज देखी तो हर क्वांटम कंपनी के नाम पे Q एक लगा हुआ होता है. एंड दिस वॉज ट्रिगरिंग टू मी कि ऐसा क्यों है, मैं भी क्या Q नाम से ही सोचूं. तो मैं एक हिंदी और आई वुड से संस्कृत नाम ढूंढने के लिए चली, और मुझे नहीं पता प्रमात्रा का मतलब यहाँ पे कितने लोगों को पता होगा. मात्रा मीन्स क्वांटिटी, एंड प्रमात्रा इज़ अ संस्कृत वर्ड विच मीन्स क्वांटम. और प्रमात्रा दैट दे डिस्क्राइब दो सबसे छोटा पार्टिकल होता है विश्व में, और सबसे बड़ा विश्व में पार्टिकल जो रिप्रेजेंट किया जाता है. तो मैं प्रमात्रा का नाम इस तरीके से स्टार्ट हुआ. थैंक यू सो मच.
Thank you very much, ma'am, including for the last delectable bit of information. You've made many important points. We'll discuss those by and by. But let me hand over now the proceedings to our next panelist, Mr. Jeewan Singh. So Mr. Jeewan Singh is from Viasat INDIA, and 10 minutes.
Yeah, thank you, Chairman, and hello to everyone. So we are talking about how we are making this secure communication to all our defense forces. So we are as a Inmarsat, and now it is being acquired by Viasat. So we are offering these Satcom services and associated with the defense forces and the government since I think last 3 decades. We started our safety services with the forces in 1990s, and then we were able to enable and upgrade the services to the BGAN in early 2010s. And then finally, we are upgrading the services to the 5th generation of the services, which we call it Global Express services, which will be able to give the high throughput services to our all defense forces. And in the coming days, we are going to upgrade to the 6th generation of the services, which would be giving the the high throughput services to them. So as we were talking about the security of the information and all, so what the offering we are doing to ensure that we have this reliable and the secure communication. So earlier we used to have a different constellation to have the services. So in cases one is down, you have to manually to switch over to the others. So now we have a provision, because once you are in a sea, then you cannot control the services. So we have the combination of the L band as well as with the Ka band. So L band, which is the one of the most reliable and the resistant services, along with the Ka band, who is offering you the high throughput services. So that you can enjoy both beauties of the communication at the same time with the different constellations. So in case one is failing, it is automatically, seamlessly switching over to the backup of the services. So this is the way we are working and ensuring the safety of the services. And apart from that, whenever the communication is happening from the ship, land or the air, so this communication is starting with the encryption, so which goes to the satellite and up to the gateway level. So we are ensuring that the communication which is happening, it is entirely secured, and it is being delivered to the gateway location. And there are the further the further components which we are using to ensuring that delivery of those services to the defense forces or any government services. So to ensure that it is not landing to the any public network, to ensure that there is no any hookups which can be done to make these services to be the ensured. And apart from this, we are already engaging with the government where we are offering to have a small geo satellites, although the sir already mentioned some challenges of geos because of the high latency and some speed related issues. But now we are working with the government where we can have a collaboration to manufacture the small geo satellites in India, and where we can offer the highest throughputs, which can offer up to 200 Gbps kind of the throughputs in a small geo satellites, where we are having a control along with the defense forces. So and utilizing our stayed on the launching and the other facilities, so that we can ensure that the satellite could be used in a full manner, either for the government civil or for the defense purpose uses. So these are the ways we are doing, and ensuring the reliability of the communication systems. So apart from that, as a geo satellite, so far it is a global express. Now in a coming year, we are going to launch our V3 satellite, which is Viasat 3 satellite, and which is having a capability of more than 1 terabit, and where we already have done the demonstration where we are able to achieve around 250 and more kind of the Mbps bandwidth. So ensuring that geo is not the left out and is still in a game, and ensuring that the safety as well as the high throughput is required to be made, so to meet all the requirements of the defense or the government sector in that. And apart from that, if we talk about the security, yes, so we are having our own security solutions, the quantum based security and other solutions. And apart from that, as we were discussing for last 2 days about the multi-orbit and the multi-constellation concept, so we are having a concept called HAN, which is Hybrid Adaptability Network, which is already been tested with defense forces, where we are having a different layer of constellations with the different gateways and the different type of equipment which is having a capability to latch on any frequencies is required to be used, because it is important to have a different layer in case of any failure of any layer or satellite or any terminal. It would be able to seamless switch over automatically to the another layer. So this is a network which we are working, so which would be consist of our geo layer, LEO layer and the MEO layer, and at the terminal side it will be the adaptive terminal which would be able to switch over to these frequencies which requires to be connected with a different adaptability of the gateways. So this is the another concept which we are working. It has already been already proof concept, and apart from that we have a democratized kind of the network which we are proposing, where it may not be easy for anybody to have this global constellation of network and controlled by a company. So there could be a consortium of like-minded companies or the countries where they can have the constellation owned by the country or the company for their own space, and they can control the TT&C, and for the rest of the places those countries will invest and do their intelligence in that, so that the common network which can be used and used by each of the countries by getting the benefit of the global constellation of the networks. So this is another areas which we are working on it, and this is much I have to say so far. Thank you.
Thank you very much.
Thank you.
Thank you very much. And now, with the press of time being weighing heavily upon us, let me turn to our pièce de résistance, as they say, saving the best for the end. We have Mr. Vinod Kaul from Gilat Satellite Networks.
Thank you, sir. Thank you, Chair, for moderating a wonderful session. And thank you, SI, for organizing again a fantastic DefSat, and wishing good luck for the next day. So I have 7 to 10 minutes. I'll take it quickly. I'll take help of a small presentation while any questions can be answered once we are on the dais. Basically, just to tell you that we are in India for last 20 years, while the company is almost 3 decades old. We basically are in the ground equipment technology. Basically, how do we communicate with the satellite is our forte. And we have a separate division under the defense, where we work globally with the various countries. We are based globally, and we work with different service providers, satellite operators, to provide basically an efficient ground communication system. In the defense solutions, we provide both airborne terminals, UAV terminals, manpacks. On the maritime side, we have specialized equipment which can connect to the satellites for on-the-move terminals, and the ground segment, the gateway equipment which communicate to the space segment. And these are the various products which we manufacture, and specifically on the military side, we are now into the very specialized antennas for UAVs and aircrafts, and then we also have portable hubs for defense forces, and very specialized military modems for secure communication with the satellites. This is one of the tactical military modem we are currently working on. I wanted to highlight the challenges which we have seen, which are faced while we are talking on the satellites, via satellites. The encryption layers, the resilience, spectrum monitoring, the low SNR and anti-tampering functionalities. So all of these are challenges, and security is such a wide aspect where it's a continuously evolving subject. So today, if you're doing X, in a short time, in 6 months, 5, it changes. So you have to have a technology, you have to have a vision, and where you continuously keep on changing based on the need of the countries, need of the network. So, we have specified a company in US which works with the US DoD, US Army, and multiple NATO MODs, offering various solutions which are around portable Satcom terminals, transportable hubs and gateways, and we also do some monitoring and control software for them. These are some of the solutions which we offer for on-the-pause solutions. And then specifically on the UAVs, we have full tactical terminals which currently will be deployed in India also with our local partners. And some of them are deployed and some of them getting deployed in the coming time frame. And coming to the topic specifically, if you see secure Satcom, we have broadly 3 elements. There's a space segment, there is a user segment, and there is a ground segment. When you look at, all of them work in tandem when we talk of, and the security is, each of these elements has to have a security of its own. Like space segment, can be jammed, can be physically jammed, can be hacked. So, we have today now new solutions which are NGO systems where we have multiple satellites operating, and even if one of the satellites are out, you can have degraded services. There's a new concept called multi-orbit Satcom systems where the terminal is working on all the three LEO, MEO, and GEO satellites, and if any of them fails, the terminal still continues to work with the communication with one of the satellites. Then on the ground segment, you have TTNC and MNC. This has to be physically secure. It's one of the most important components of a space of the overall network. And we suggest that it should be generally in redundant modes and incorporate encryption and various security measures. Then on the user segment, which is where the modems and other technologies come into consideration, the level of security changes. There's a need of COTS. There's a need of flexible system. So it's a very complex way of how much secure we need. So it depends on the need of the customer, and the security can be defined based on the need. It has commercial considerations also. You can have a very highly secure system, but the commercials may not allow you. But so depending on the kind of need, one can define what kind of security it has, and today's technologies allow you to have that kind of deployments. Just an analysis, cyber attacks on space segments over the last many years. So if you see, the signal is one of the highest where the cyber attacks have happened, and that's where we have to be more resilient and more working. So how do we see challenges and where we are working on it? So like the NIST special publication framework talks about many elements of how do we on the cyber security when we look at battlefield resilience and Satcom systems. These are various points which today's technologies are implementing, and this keeps on changing. When we talk of hub zero trust, or when we talk of irregular penetration testing and NSS scans on the deployed systems. So this is an ongoing process, and we all these technologies which are to be deployed on the Satcom follow these processes to see how they are done in a right manner. When we talk of TRANSEC, so like we do follow FIPS 142 standards for TRANSEC, and which is one the chair talked about. How do we manage the communication? But yes, it is not that TRANSEC is needed for everything, but depends on how critical the communication system which you are deploying is, and based on that it can be used or cannot be used. Then we have COMSEC, the communication security, where we're deploying AS256. Standard today is quite prevalent in most of the Satcom systems which we deliver in India or anywhere else. We also use very specific authentication, which is very unique, called X509 authentication, where the terminal is authenticated before it is deployed in the network, and these certifications are done locally by India, and we get them implemented on our network. That's it, sir, from my side.
Thank you very much.
I hope I was at the time.
Yes, thank you very much. Everybody was.
Thank you, everyone.
We have a few minutes left for some audience interaction. If you have any questions, yes, sir. Just introduce yourself for a second so we know who you're saying.
Namaskar. My name is Devesh Upadhyay. I'm Director of Hardai Engineering Solutions, Jaipur. My question is for Richa ma'am. I want to ask that I've gone through your website, and since photons traveling is not of a far distance and you are developing a chipset for QKD, that's a remarkable thing. I want to ask that building this chipset need a quantum dot materials. So are you synthesizing this material in-house, or how are you doing that?
That's a very good question. And in fact, I highlighted in my talk that for being resilient as an ecosystem, we need a photonics fabrication ecosystem. In chip development process, there's one part of IP is the design of your circuit, and the other part of the IP is the fabrication material. There are various materials which are quite common, not just quantum dots. Quantum dot is one application which is used for. There are silicon nitride, gallium arsenide, indium phosphide based, photonics based solutions which are quite popular, and in the European ecosystems, the fabrication has also been scaled up to larger capacity. So the design of our chip is proprietary, fully designed at a component level in-house, and we are taking support from a fabrication facility in Europe for the same.
Okay, I just want to add that.
Just one at a time, because we have one more question. If you just pass the mic on to your...
No issues. I just want to add one point, that Hardai Engineering Solutions is standing for synthesizing this quantum dots in other materials. Thank you.
Wonderful. Thank you.
So good afternoon, I am Anupam Tiwari. The question is open to the panel, or more specific to Richa ma'am. There were 2 news bites in last 6 months wherein National Cyber Security Council, United Kingdom, they have come out on their websites and they have released a white paper wherein they say they do not recommend, advise, and endorse the use of QKD for government and military communications. And secondly, 2 weeks back, there was another research work wherein on a regular internet traffic, quantum teleportation was achieved for a 30-kilometer distance, wherein a photonic state without physically traveling was achieved at the user end. Thanks. Your comments.
Well, I just wanted to take a stab at the teleporting issue. The ability to teleport single protons or single quarks or single elementary particles is a well-established one. The problem is that once you go into a larger commodity of any kind, we are still somewhat distant from that. So I think that I will put that my 2 pice bit. And
yeah,
hand over to
I
you.
agree on that. That see again, I was telling that there are myths revolving around, right? So yes, there is a need of single photon source, and I would say more than a need of single photon source, there is a much larger requirement for highly accurate single photon detectors, right? You can have a photon source which is generating multiple photons, and still if you have a detector which is just measuring single photon, your communication and your cryptography can be implemented effectively. So, but that doesn't mean that, yes, it's dependent on the communication technology and the protocol that you use, that whether you want to implement your protocol which is dependent on the single photon communication or still via a multi-photon communication, you can still establish your cryptography. So these are the myths. It's a start and advancements that take place at a slow pace. Just answering your first question on the news articles, right? I think it's very critical and sometimes strategic as well. And I think this is not the last year. That's much earlier. NSA had released the article that they don't favor QKD. But if you read through clearly those articles, they say that these are the 4 to 5 limitations of QKD technologies, and which even Navjot sir quite highlighted in his speech very critically. And if these limitations are met, QKD technology can be implemented and can be much more sturdy. So you have to read between the lines at times on what is strategic and what is more, how we have to take that as in ideas and thought process for the next generation of technology.
So we are at the end of our allotted time. I wanted to make only 2 points. One was to reinforce what Richa has just said, that some communication is strategic and miscommunication is also an old-fashioned technique. And the last point I wanted to make, apart from thanking my fellow panelists, which I'm sure you will join me in doing in a minute, is to say that this is to militaries. And it is particularly to the senior leadership of the militaries who, as I've already mentioned, are facing the challenges that we have already spoken about. Should militaries then, here's my question for you to think about, should militaries then concentrate upon ground stations? Is that the correct point of application of force? Because this immediately places militaries in a more comfortable position. There's a physical entity. You are able to map it for yourselves, for your enemies, and therefore, should the military offensive impact, should the military's offensive thrust line not worry so much about whether or not we can or cannot break or have our own crypto algorithms broken, but to concentrate upon the ground station, because if the ground stations aren't there, then the rest of it doesn't work. It's just a thought for you to ruminate upon, and I'm always of the belief that Occam's razor is a good example. In any given complex situation, the simple solution is probably the correct one. Now, with that, I think it is only apt that I request you all to join me in thanking our panelists for the brilliant presentations they made, and for pretty much staying on time. So thank you, each one of you. It's really been a hard task, I know, but many, many thanks. And last but not the least, let me say thank you to SIA, whose leadership is sitting right in front of me. Thank you very much for giving us the opportunity.
Thank you very much, Chair and the panelists, for highly insightful discussion. We can have a group picture before we proceed, move on to the next session.
One part of the
And we can be here.
Please close. Yes. Thank you so much. Thank you very much. Thank you very much. Thank you, ma'am. Thank you so much.